Hey, what's up everyone? Welcome to the stream. So, I did a little bit of work since the last stream, and I'm happy to report that I was able to finally get the audio that we were able to capture to a WAV file, or to a RAW file anyway. I'm finally able to get it to come out of the normal speakers that basically plays through the sound card. And getting that to work wasn't too bad. We had a couple of little things to fix, but the main, and this was actually at the end of last stream, so if you're watching you would have seen this, that the main thing that we had to fix was actually, it's a bug that had laid dormant in my audio driver for a while, and I actually need to go fix this in my other emulator. And that was the fact that when I was using this open audio device, I had to make sure to pass a value here for allowed changes to be 0, meaning don't make any changes. This is a very, very important flag, because if you don't tell it to not allow any changes, what ends up happening is that although you request a desired format, it can actually return a different format, and then you're supposed to respect the format that's returned, which is not what I was doing. I was just assuming the format I asked for is what we're going to use. Now if you say allow changes is 0, what SDL will do is it'll say, okay, you know, this is what you want, this is what you get, I'll do the conversion for you. So it's actually a really nice feature. Probably has some overhead, but whatever. That just allows me to keep my code nice and simple. You know, maybe later if I find that this overhead is actually a problem, I could go and fix it, but I don't think that's going to be an issue in this emulator. So once I got that, everything was working, and basically what it boiled down to was the main difference between what I asked for and what was returned is that I was asking for a 1 channel buffer. You see here the number of channels is set to 1. And I was asking for it at 44,100, and what I was getting back was something at 44,100, but with 2 channels, right, left and right. And when that's the case, you're supposed to produce twice the number of samples. You have to produce a sample. Every sample is basically interleaved, left, right, left, right, left, right. That's typically how it works for 2 channels. If it's more than that, you have to produce that many samples per channel. It's all interleaved. Now, I wasn't doing that, and what we were seeing was that at the rate I was producing samples, I was effectively starving the audio thread. I would basically pause, start filling up the stream, and then as soon as it would start reading, it would end up like completely reading and then going back to below my threshold of 10% and then raising up and going back down. And so since the audio thread was trying to consume twice as many samples as I could give it, we were constantly getting into this weird, you know, in fact, we could actually see it. It was kind of like a zigzag, although maybe we won't see it anymore. Yeah, it's not so obvious. But anyway, the point is that we were not able to feed it at the right rate. And as soon as I told it, don't allow any changes, now I can feed it at the exact rate that I desire, so that is 1 sample instead of 2, and everything works. So that's really cool. The other thing that I've done now, that was at the end of last stream, so if you were watching you saw me do that, and it all worked out. After that I fixed a small bug, not worth talking about, but more interestingly is I ended up fixing the fixed volume case that wasn't working, and it's kind of funny. So the issue was that I had been reading, you know, the documentation here, and it says quite clearly that I'm supposed to grab the amplitude values from registers 10, 11, and 12, right? And it says that everywhere, R10, R11, R12, R10, R11, R12. And so sure enough, in my code, I was looking into those 3 registers. However, it wasn't working. And then as it turns out, and actually Pyro ESP was one of my, you know, he's been watching and following for a while, and we chat sometimes. He had actually mentioned this a while back, and I kind of forgot about it. He had said that the values that were being, the register numbers were actually in octal form. So I didn't realize that, right? And so what does that mean? In fact, it became kind of obvious to me when I was looking at, yeah, this table here. See how it says R0 all the way up to R7, and then instead of R8, it says R10. And then R11, R12, 13, 14, 15, 16, 17. And I was like, oh, that's weird. And at the time I said, that's weird. How could there be 17 registers? And that's when he had said, oh, it's an octal. And it didn't clue in. But sure enough, after 7 in octal, the next number is 10, 10. But see, I just read that. I didn't see this table. I just read it independently in that section and thought register 10 in decimal. But this is actually register 8 in decimal, 9 and 10. So the big fix for making the volume stuff work, the amplitude stuff work, was literally changing my enum here to contain 8, 9, 10. Now I ended up filling in the rest here, which actually makes more sense. Now I actually have the 16 registers we're supposed to deal with. But there it is, right? And I guess I should have clued into the fact that the registers were increasing linearly, 0, 1, 2, 3, 4, 5. Although, actually, I don't have 6 in here. What is 6 again? Ah, the noise period. So I guess we'll have to add that. But then 7, and then it should have been 8, 9, 10. So once I did that, and then I re-enabled the original code that I had for, where is it here? I had commented out the code and I was returning 1. Now I'm actually returning back the fixed volume. This actually does the right thing, and we actually get something that sounds a lot closer to the actual Vectrex. So I'm going to stop my music here, and I'm going to do a little demo. I'm going to drink some water. Oh, I'm going to put this over here. Now this is going to be really loud, so let me just lower it. Or is that too? Let me see if it's too loud. Oh no, that's okay. So, see what you heard there? I'm going to restart here. I'm just going to play this again. Hey, Moosey boy. Hey, man, thanks a lot. By the way, is that audio capture like clear? Because I'm looking at OBS. It seems like the levels should be okay. Or is it like too loud, or let me know if there's a... It's hard for me to know because I can't hear what you hear. See now, so what we're hearing now are the three channels. All we've got so far are the tone generators on the 3 channels, along with the volume for the 3. Yeah, so it's really close. There's some minor glitches, and I'm pretty sure I know what that's about. But it's extremely close, right? The minor thing just has to do with the fact that I'm not interpolating correctly over time. So there's like slight discontinuities in the way I'm computing the signal. So you can sort of sometimes hear a little bit of weirdness in there. And then there's a couple of pops and stuff. But honestly, it's really quite good. So I think we're making some good progress here. So yeah, very happy about that. Let me see here. That's not what I wanted. Oh yeah, here on my to-do list. Yes, I also did another thing, and I don't know if let me see here. Oh yeah, no, hookup. Where did I do that part? Anyway, I don't remember, but I also fixed the fact that things were not centered around 0 at some point. I think that was part of my big check-in here. Yeah. So basically, if we look at the captured audio, because I think it's still enabled. Yeah, it's still enabled. Yeah, you can see it already. these are captures of the last things. You know, I'm going to just delete all this and just re-import. And what am I capturing again? Is it source? Okay, so it's the output. So then that would be in signed 16, one channel. No, that was not right. What was my format again? Signed 16. Oh, isn't that right? It is right, but this is weird. I guess I do have a bug in there. Not that it really matters too much, but I'd like to get it correctly centered. Why isn't it centered? So I have a ratio from 0 to 1. I subtract 0.5, multiply by 2. And then what did I do here? Okay, let's see what's happening. What's wrong here? So let's see. If sample, let's just force it here. I just want to see. So if sample is 1, $32,766. Yeah, that seems right. And if sample is 0, minus 32, yeah, that looks right. And then if it's 0.5, it should be 0, which it is. Oh, okay, I'm not writing the target sample. Still writing, okay. Yeah. So actually there's nothing wrong. It's just that I imported as signed, but in fact, yeah, I guess I should, what should I put here? I guess technically I should write the target sample here, because that's really what I'm feeding. Since I have these different debug options, and if I'm not writing out the source samples, I should be writing out the target samples. That's what I kind of mean by that. So let's do another capture here. Yeah, those little pops and stuff is what I think I'd have to look at. But those are polish fixes. Now we import signed 16 single channel. It's not right again. Signed 16. It doesn't really make much sense, unless So the zeros are minus 32,000. I guess it's the scale here. Is it's rescaling it? Sine 16 really is minus 32,760. Yeah, it's not quite the right value, but it's okay. It's close. Why isn't that not right? Basically, my range here is always 0 to 1. If my sample is 0, it's at the bottom end, minus 32,766. If my sample were 1, it would give me 32,766. That's the top range. And if it's 0.5, like I did this before, I should get 0. So that should be centered around 0, right? This is 32-bit float. Why does it say 32-bit float? Don't understand. I know that if I capture the actual floating values, floating point values instead, so the source samples, then it looks correctly centered around 0. Import. So now if we pick float, it's 32-bit float, one channel. Oh, still wrong. What's going on? Okay, like I'm not understanding this. Oh, okay. Okay, yeah, sorry, I got this wrong. This was supposed to be sample. This is the source sample that I'm adding here. For the target sample, which we push back into this array, that gets, so if source samples is false, okay, I just got confused with my own code here. So this is the target where we actually, okay. Forget everything I just said. I think, anyway. If I let me just try and do another capture with source sample set to true. So now if source sample is set to true, this should be floating point. Okay, I'll just stop there just to see. Let's try float, little endian 1. Yes, strange, still not centered. All right. Oh, that's interesting. That does make sense. Inputs are always in 0 to 1. It's only the output that's going to be remapped. Okay. Yeah, that makes sense. I wonder if I should remap just for... No, I guess I'll leave it like this. In a way, it's kind of like, maybe I shouldn't be using 0 to 1 as my range. But I find like it's just easier to think about it that way and then just worry about the remapping for the output. So if I put false here and do a capture, we should, in theory, get 16-bit values centered around 0. 16-bit sign values centered around 0. And it's not centered around 0. Strange. I'm not sure what to make of this. Okay, let me see. So it's the values coming out of the samples. You know what? Yeah. I think I realize what it is. Yeah, let me try something. If we put unsigned 16, what does this look like? Oh, there's no unsigned 16. But yeah, that's what happens. Yeah, so I guess maybe I just need to think this through. So what does it mean to be 0, right? Shouldn't 0 be no sound? For me, 0 doesn't mean that. And maybe that's something that's not correct. So here the bottom is no sound, and then this is sound here. And I think my range doesn't surpass. Okay, let me try something. Sample, add sample. Static float min sample f Just want to see what our active range is. Because I realize actually we're probably not producing the full range of 0 to 1 right now. What did I do? Looks right. Oh, whoops. This should be min sample. Wait. If sample is less than the min sample, set that. If sample is greater than max sample, set max sample there. Okay. And oh yeah, and output max. So we should see our range. Okay, see, that's what I suspected. We're never surpassing the... that's confusing. Yeah, that's kind of tricky. Basically, we're never surpassing the 0 to 0.5 range. And that's because I haven't actually implemented the noise channel. Okay, so that makes some sense now. That explains why we see these kinds of curves here. That basically we are getting just this range so far. But now that I'm going to implement noise, we should get the full range. Okay. So nothing to worry about there. Let's focus on implementing noise tonight. So let's drop down to I'm going to skip this for now, which is the envelope stuff. We're going to come back to that. And we're going to focus on the noise. Oh, I think I missed it. Here we go. All right. The frequency of the noise source is obtained in the PSG by first counting down the input clock by 16, then by further counting down the result by the programmed 5-bit noise period. This b-bit value consists of the lower 5 bits of register R6 as illustrated in the following. So this is very similar to the tone generator. Note that the 6-bit value in R11 is a period value in R11. Period value The higher the value in the register, the lower the resultant noise frequency. I guess they meant R6. Note also that as with the tone period, the lowest period value is 1. The highest period value is, divided by 3110. The noise frequency equation is this. It can be seen that the noise frequency can range from a low of to a high of this using a 2 MHz input clock. Okay. To calculate the value for the contents of the noise period register, given the input clock and the desired output noise frequencies, we simply rearrange the above equation yielding this. Okay. So I'm guessing then, if I understand correctly, all this does is produce a 1 every time? For what? Like for one cycle? How does this work? The value for the contents of the noise period register. Okay, so I'm missing a little bit of information here. Let's see here. Come back to this. Total of 31 different cycle times. OR-based mixing function for combining noise and tone on its 3 channels. The chip uses a simple OR-based mixing function. Oh, that's interesting. So that just adds the 2 values. For combining noise and tone on its 3 channels, sure, and could be persuaded to produce a level non-zero wave. And a white noise generator. Noise pitch. The chorus and fine pitch registers for each channel are used in the following fashion. Registers 0 and 1 operate together to form channel A's final pitch. Okay, that's for the tone. I'm not sure what it is. Like, what is it supposed to generate? What is white noise anyway? Unfortunately, it doesn't explain exactly what it's doing. A total of 31 different cycle times. Okay. It doesn't really explain, though, how the noise is generated, or what the shape of the noise function looks like. Not sure I understand how to do this. Wonder where I can get information on what the noise generator must be doing in this chip. What's this here? The random noise is also produced through a square wave. Aha! The period width of the square-shaped pulse of sound affects its tone. So what's the difference between that and the tone generator then? Am I misunderstanding it? I think that's what we already have. looks very similar to what we already have. And that looks just like what we have, yeah. So not too useful. What? Oh, that's okay. Dropbox trying to be helpful. Well, I guess I thought I would be able to figure this out by just reading the docs, but not quite sure I understand. What I don't understand is that one of the docs that I found says, where is it? Yeah, I think it was this one. Noise. We can output pure tones or noise. The random noise is also produced through a square wave. The period width of the square shape pulse of sound affects its tone. So what do they mean by this? That the random noise is also produced through a square wave. Is there like a completely random bit pattern for the duration of the square wave? And by complete random, obviously I mean pseudo-random, but what does it mean? I'd rather not look at other emulator code for this. Let me see something. Maybe if I look at my NES emulator, it'll inspire me. Okay, this just sets the period for the noise channel. And we have this linear feedback shift register. So what is this? So it is based on a shift register. Clock by the noise channel. Okay, let's see here. Maybe we'll get a clue by looking at, where is it? Maybe the circuit diagram? Noise generator. Produces a frequency modulated pseudo-random pulse with square wave output. Nothing. let's see here. So I read bit 0. Then, depending on the mode, it's either bit 1 or 6 that I read. Bit n. Feedback is bit 0 XOR bit n. And then the register value is equal to, we shift to the right, and then we take the feedback and we put it into the left by 14. Okay. Now this okay. So I know for the NES we had way more information on exactly how the noise generator works. Like there was this whole thing about setting the mode, which selected which bit it uses for the next bit, that it actually XORs with the value of bit 0 to produce what's called a feedback bit. Or the feedback, yeah. But I don't seem to have this kind of information for the noise generator. Oh, hey, Pyro. How's it going? Maybe you'll be able to help me. I'm trying to find information on how the noise generator exactly produced its signal, you know, in the sound chip. Basically, all it tells me is that we have the ability to set the noise period to a from 0 to 31. So we have like a 5-bit value that we can set for the period. And apparently it uses a square wave generator itself, but it doesn't explain what kind of pattern the pseudo-random noise takes on. Now I was looking at my NES emulator, and it used a linear feedback shift register that had 2 different modes and would produce basically the pseudo-random sequence in a specific way. It would basically grab the low bit out of the shift register, and then depending on one of 2 modes, it would either select the next bit or the 6th bit, read it, and then produce a value that was an XOR of bit 0 and that bit that we just read, 6 or 1. And then it would restore into the register. It would basically shift right and OR it with this value, this XORed value that we produced earlier, shifted left 14. So this is a 16-bit register. And that's how the one for the NES works. And there's a lot of documentation on that, and that's how I was able to implement it for the NES. So far, for the AY3 8912 or 8910 or whatever, there's different variants. It doesn't explain at all. Anyways, I can't seem to find anywhere what hardware-wise it was using, for generating noise. And I mean, there's a part of me that wonders how important that is, but yeah, basically that's where I'm at. Did you have any idea? Yeah, it doesn't seem to be giving much information. Ah, wait a minute. What about this? I might have found something. Aha. The noise generator consists of 17-bit shift register and a 1-bit noise level. These are updated at the selected frequency as follows. Aha! Noise level is noise level XOR shift register bit 0. The new bit is bit 0 XOR bit 3. Shift register is equal to shift register shift right by 1 plus the new bit shift left by 16. Okay, there we go. So I will do this. This time I looked up the chip along with shift register. So I figured it would be implemented with the shift register, and I found this. So this looks good. So let's do this. You came in right on time, eh? I was actually staring at docs for like the last 10 minutes or something, trying to figure this out. I'll call this I kind of need to do a lot of the same things I was doing for the tone generator. So maybe what I'll do, So it must be late for you. Was it like 3 o'clock or something for you? $4 a.m. Man, you go to bed so late. I can't believe it. Don't know how you do it, man. What was I calling this back? Yeah, it was a timer. You don't work today and tomorrow. You start Thursday from 2 p.m. to 10 p.m. Yeah, so you work night shifts, eh? What do you do exactly that requires you to work at night, if you don't mind my asking? You don't have to answer. Sounds rough, man. I work as an electric and instrumentation technician. That sounds interesting. And that's something that is needed at odd hours in a day? Hey, these are not supposed to be no inline. Forgot to remove those. So let's see here. Void set period. Okay. clock. All right, so now I have a timer. Okay, now I'm going to break everything and write it in terms of this. I can only spell. Okay. Okay. Also, Pyro, you since you just like joined not too long ago, you did not hear what this sounds like yet, right? Well, I mean, that would explain why you're so good at electronics. I heard the end of last stream. Okay. Yeah, so you'll hear it very soon, assuming I don't break everything. If the timer clock returns true, then we do this part. Right, so you're an electronics guy. That's cool. Well, it's been very helpful. All right, so that takes care of the tone generator, because I'm going to be writing the noise generator in terms of this. But let's just see if I've broken everything. Unused variable. No, unreachable code. All right. Yeah, probably want to return after I set the time. Oh, actually, this is not right. Hey, where's my audio? Okay. But I was thinking about this. This is just for square waves though, right? It's not actually what I want. Yeah. No, okay, that's not quite right. Okay. No, that's not what we're going to do. What we're going to do here is the duty does not belong there. Which is also why this wasn't working. I forgot to call update duty, but it's okay. We're going to do this differently. Basically, we're just going to do this. That's how it should be. Just set a period, and yeah. Now, the tone generator is going to work a little bit differently. We're going to remember the period here. So I'm going to actually undo everything I just did. It's okay. I'll figure this out soon enough. And I'm going to actually do update duty here. But I'm going to call it update timer. We're going to call update timer instead of this. We're going to bring this back to how it was. Okay. Now an update timer, I'm just going to do this. Let me just see. Yeah, I think that's good. Still no audio. What have I done? If time is greater than 0. Yeah. Yes. What was that deal again? Okay, if time is greater than 0, and all right, no, that's okay. We're still doing that in the clock function. Then we reset it and we return true. Otherwise, we just return false. Ah, but we're not advancing time. Oh no, we are. We're doing minus minus time, so that's okay. And then we reset it to the period. Okay, let me just see if I did something. Will stash just change? Just want to make sure this actually works. Okay, so there's the sound. So I did break it with my changes. Just playing this for you, Pyro, so you can at least hear it. Hear that glorious square wave. Alright, so let's pop this back and let's figure out what's going on here. Sounds nice, eh? Thanks. Okay, so let me think a little bit about this. Only 4 bits should be set, period. Let me go back over my diffs. Ah, okay. There's the bug. Yes, yes, yes. Okay, fine. I'll do it in 2 steps. You know what I'll do? We'll call reset time. And reset time. This should work. Unless I made another mistake. There we go. All right, so now focusing back on the noise generator, we'll have this shift register, we'll have a timer, because there's some similarities with this guy, except it only accepts a 5-bit value for the timer. Oh, actually, I'll call this period. Okay. So let me look at this here. I should probably put this in its own class. Anyways. I don't know why I made the 16-bit value. I don't know. Shift this right and do this OR with the new bit shift left 16. It's 32-bit value. Maybe I won't do this. Okay, but I don't want to clock it every frame. So this will be whenever the timer gets clocked. If it returns true, it means it's time to do this. Okay. So hopefully I got this right. Oops. why did I make this a 16-bit value? Let's see if I can figure that out. Tone generator, sample. Seems completely arbitrary. Let's make it 32-bit. Same thing here. Let's make all of this simpler. Oh, I missed that one. Okay. Okay, so this builds. So now we have a way to have a noise generator. So let's add a noise generator instance. We only need one. Great. Next. All right, and noise generator. And I just need to make sure to update the noise generator in the clock function. So we've updated the tone generators and then the noise generators here. Oops, it should be tone generator. All right, let's see if it works. It's possible that the noise generator will not sound correct until we have the volume envelope implemented. From what I read, it looks like you often combine the two, but still, we'll get some idea of it anyway. Okay, so it doesn't look like I'm getting much here. Let's see here. We're clocking it here. So maybe there's a bug in this code. And of course I can't step into it. Oh yes, forgot something. I am not setting the period on the noise generator. That might help. Okay, so that's gonna come down to which registers we need to do this on. It's going to be an R6. Okay, here we go. The low 5 bits of register R6. It's the one register I haven't written. Noise. Noise generator control. I should probably rename these. I'll just put a little to do. Maybe something like this. Anyway, whatever. Okay, so because that makes more sense. Anyway, especially following what is in the data sheet here, it is called the tone generator control registers, and we're calling this noise generator control, so just to be consistent. And we want the low 5 bits, and that's pretty much it. So very similar to what we're doing here. So when we read from the noise generator control, we just ask the noise generator to get its period. That's that. Similarly here, when we write to noise generator control, okay, let's try now. Okay, that's a little disappointing. Let's see if I am gonna hit the write that I want here. Okay, I just pressed fire. Oh, hey, thanks for the follow, Clutch9K. Appreciate it. Okay, so we have a value of 31. So there's the period, 31. Time has been reset to 31. Oh yeah. Obviously having a shift register initialized to 0 is not going to help us very much. That would not make much sense. What did I initialize my... What did I do here in the... I put at least a 1 in there. All right. I mean, having a 0 it means we'll never get values, so we have to at least initialize it to 1. I think that probably makes the most sense. Let's go back here to the noise generator. We'll get there. Okay, I'm just gonna fast forward. This might sound awful, but I apologize. Still nothing. Definitely when I fire, it looks like it wants to generate noise. Okay, so now our shift register definitely looks like it's got something going on in there. Let's see. So our value is 1. Our current time is 18. So what's going on here? Are we not getting our values here? Sample channel and mix. So for each channel, we are passing in the same noise generator that we've clocked once per every 16. Over here, maybe this mixer control thing is not working. Let me see. That's possible. Why are we not getting this? Hold a second. PSG. Let's disable optimizations. Okay, so we are getting something here. So it looks like, okay, because when everything is 0, everything's enabled initially. All right, let me just skip the initial stage of it and come back here. All right, so now I'm not getting anything. Again, I apologize for the popping. Okay, so I just hit F5 and it looks like we are trying to get a value out of our noise generator here. And we are getting a value of 1. That's interesting. Sample 1 times our volume, which is really low. Okay. You know what? This may be the envelope thing. Although we would get 0 in that case, wouldn't we? Yeah, that's true. So no, it's not that. Let me just... Okay, so now I just press fire. We got a sample of 1 from the tone generator. Sample is 2. Volume is 1. So right there, this should have produced oh, wait a minute. I did not implement this correctly. There's feedback based on the last noise level value here. Okay. It's supposed to be value is equal to value XOR the 0th value. Okay, so it's not quite right. Let's do this correctly. So we take bit 0, we take our old value, which is the noise level, XOR it with bit 0. We read a new bit, which is basically bit 0 again, XORed with bit 3. Let's rip that out. And then the shift register is shift right by 1 and XOR with that new bit shifted left by 16. All right, let's see if this gets us any further. Oh. So that definitely sounds like noise. Not the right noise though, but that may be the envelope thing, maybe. Let me see. Or maybe there's still a bug in there, which is very possible. Yeah, damn it. This is one of the things about debugging lambdas is that they may get inlined. Let me see. Can I? disable that, see if that works. So much popping. Alright, so it doesn't look like we're hitting this breakpoint. Definitely hitting this one. Oh, and then now we hit the 0, 1. So it looks like when we get hit, we're supposed to get the envelope volumes there. So you know what? That must be why when I blow up the mines, we're not getting anything, because that must be using the envelope. In fact, what I'll do is I'll change it to 1. See? As soon as it explodes, it comes in here. So just to see, let's put 1 here and see what that sounds like. Yeah, it's relying on the fact that the envelope will stop the noise. Okay, it's just annoying. Okay. Yeah, I also realized we're not making sure. Yeah. Okay. Okay, that doesn't change anything. I'm just thinking. You know what? I think I know what's going on here. It's a 17-bit register, right? So there's one question I have is whether this is one of those registers that rotates. Was it like called a barrel register or something? Oh no, it's okay. This always shifts right. And the new value gets, so this should always be less than 17 bits. Yeah. So that's not it. So I got my assertion. That's interesting. And 1 shift to 17. Reset. Sorry, I'm gonna say your name wrong. Resetu CSGO. Do you have experience with synthesized sound samples? I don't know what that means exactly. What do you mean by synthesized sound samples? Well, I mean, I wrote an NES emulator where I had to do this kind of thing. Oops. I think I'm going to need to do this. No, not quite that. Actually, quite understand though. Why would this go above? Coding the control of the mouse movements and pressing the keyboard buttons. It's all right, Rasset. I don't know what to call you, but I'm gonna just keep hammering at this. I'm pretty close, I think, here. I'm just got to figure out. I think it's more of a frequency problem right now. I'm not sure if I'm doing this right. That basically the noise consists of 17-bit register and a 1-bit noise level. These update a selected frequency as follows. Yeah, I think I am doing this right. In hertz. Mm-hmm. I see you are not fast coder. Okay. Yeah, I think this is not right. I don't need this. This has to be 18. Wait a minute. Wait, 3. Oh, wait. Oh, yeah, okay. I see my mistake. I have to shift bit 3 down into the 0th position. So then when I XOR, I get the real XOR value between those two, which is in bit 0. Okay, that makes more sense. Let's see if that works. Aha. Aha. That actually sounds right. I mean, I need to do the envelope, which is why we hear that it doesn't end here. But I'll just restart again. Yeah, that was my bug right here. I had to shift 3. I basically was getting always bit 0 XORed with 0. So that wasn't working at all. Yes, explosions. So like that sound there, which it may sound a bit horrible, but that's actually the real sound in the game. Let me see if I can bring up that. I think we had found a Mindstorm on YouTube. Mindstorm Vectrex. We can maybe hear the sounds. Let's try. No, we'll try this one first. So that the quality there is not great, but you can hear the noise in there. Let's try this one here. I don't know if we'll hear it well.
Rocket ship, you need to be an optimist.
Yay, ads.
No astronaut launches for.
All right.
Console. It's like its own television screen and hope that you're not crushed. The Vectrex controller has 4 buttons. It has a lot in common with.
So you hear that very high-pitched screeching sound when you move, and the noise. That's supposed to be everything you hear in the noise. So let's see if we get. It's possible that mine are not as high. Yeah, there you go. See? Yeah, it does sound pretty good. That is some serious noise. So, I'd say that's a success. Thanks, Pyro. I have to say, because like, I'm still in awe at the fact that audio can be produced by simply shifting bits and, you know, playing with counters. Like it still amazes me that, you know, I'm writing this emulator and all I've got is these little, you know, integers that are counting down and flipping an integer 0 or 1. And sure, there's a little bit of, you know, pseudo randomness being generated here, but it's just like int values, you know, and counters, and all of that is enough to produce these signals that actually sound like music or, you know, like sounds. It's crazy. Anyway, I'm still impressed by it. Yeah. Tone generator, noise generator. I definitely need to move this code somewhere else. But for now, it's okay. While I iterate, I'll just keep it here. Next up will be the envelope volume. So let me get this committed. And okay, so this I don't need anymore. That's just a little test to see if we're getting those samples. Okay, that looks good. Implement noise generator. Let me push that up. All right. Well, guys, thanks for listening. I'm gonna sign off and continue in just a couple nights. So if you want to join Thursday night, usually start around 9 p.m. over here Eastern time, like I did tonight. And the next thing we'll do is we'll work on the envelope, which looks like an interesting piece to work on. We've got over here. Yeah, so it's part of amplitude, and it's right here. So the variable amplitude control. So it's going to be basically implementing this stuff related to the envelope period control, envelope shape cycle control. No idea what any of this is, but we'll read about it. Looks like we want to get these kind of shapes going. Sawtooth and all that. Hopefully not too bad. I don't think it'll be too bad to emulate this. And then after that, we should have pretty much everything we need for audio. And yeah, and then I think I'm just gonna have to fix, like I was saying, I have some discontinuities in the signal that I'm producing because of the fact that basically the sampling, the resampling that I'm doing is not like, you know, a perfect multiple. Like the number of CPU cycles that have to pass before I need to produce a sample for the audio driver is not a nice round number. And so I think I'm not doing the interpolation logic correctly, and that's why there's these minor like slight glitches in the audio output, I believe. I need to like look more deeply. That's the part of audio, of implementing the audio, that's like less fun. Figuring out why you get the little pops and the little discontinuities there. But I'm pretty confident we'll figure it out. So yeah, I'm gonna end it here. Thanks again, and I'll see you guys in a couple days.